Okay, this problem says, given the geometric series here that represents some function f of x, find this function. Okay, this is an integral function, which looks like it's the antiderivative of f. So the first thing we got to do is find f. This is a geometric series, so we'll use that to our advantage. So recall, anything that fits the form of a geometric right? So we know this converges to a over 1 minus r if r is in between -1 and 1. And so when you do this with a power series, you don't get a number when you apply this formula here. You get a function, and that's going to give us our function f of x. So let's just write this all out. So I've got so -1 to the n, x plus 1 to the n. Let's write out the first few terms. When you plug in a 0, you get 1. And when you plug in a 1, you get negative x plus 1. When you plug in a 2, you get positive x plus 1 squared. And then negative x plus 1 cubed, etc. So that'll converge to, if we use our first term, so our formula up here, first term is 1 over 1 minus the common ratio. So the common ratio is, it looks like it's just being multiplied by x plus 1, but the sign's changing. So it's really negative x plus 1. Okay, one way you could also do that is you can manipulate this, right? This is the same as -1 times x plus 1 to the n, right? If you do a little manipulating the general term. In any case, we'll clean this up, and this is going to be, let's see, 1 over 1, so this negative will make that a positive, or those two negatives will become positive, 1 plus x plus 1, which is 1 over x plus 2. So now, so this is my f of x, right? That's f of x. So now let's turn to what they're asking us to do, this thing up here. I can do that by, I'm just going to do exactly what it says. It says, right? So in terms of, instead of f of t, I'm just going to put, or instead of the function I have here with x, I'm going to use t. So this is 1 over t plus 2 dt. Okay, and we know the fundamental theorem can help us here because we know an antiderivative of 1 over t plus 2. It's natural log t plus 2 evaluated at -1 and x. Okay, and so then when I plug in an x for t, I get ln x plus 2 minus natural log, and -1 plus 2 is 1, and natural log of 1 is 0. So your final answer should be this. Okay, this function here, that function there is the is like a closed form, right? This here is a closed form of this integral looking function, and we did it by manipulating our geometric series up there, using that formula, getting a closed form function for f of x, and then using some calculus.